So I'm Andrew Morgan. I'm a developer advocate with MongoDB, and this session is aimed at people that are familiar with application development but have never actually built a mobile app. So I'm going to show you how to build your first iOS app. And if you want to follow that QR code, that will actually take you to the repo that's got a bunch of resources, but also all of the code that you're going to see today. This is the app that we're going to build. And it's a very simple chat app where we've got a hard-coded list of chat rooms. You can go into a chat room and then exchange messages with other people that are also in that chat room. So a very simple version of Slack, if you like. Okay, so coming from MongoDB and Realm, it's all about the data, so we'll start there. So what happens is that when you actually send a message into a chat room, that gets stored into a local Realm object database. That message is then synced with the MongoDB Realm service in the backend, which in turn will sync it to any other instances of the app that are running. In this case, I'm going to have 2 copies of the iOS app, but it could just as easily be an Android app. And as a bonus, that data is also going to get synced to Atlas. So for example, if you, Atlas is MongoDB as a service. So it's where we host MongoDB in the cloud and you just store your data there. We're going to partition the data. So why do we partition data? There's a couple of reasons. The first is capacity. If you've got 100 million users, you probably don't have space to store all of the data for all users on everyone's device. So you want to partition. Also, if you've got sensitive data, I don't necessarily want you to have my bank details running on your device. So the partitioning we're going to use is based on setting an attribute in every document or every object. So in this example, we're using the color. We've got different shapes collections. And so when we sync, we can say we want to sync all of the blue shapes, all of the red shapes, or all of the green shapes. And for our data, we're going to use the name of the chat room as our partition key. So, for example, we'll set the partition to Swift, and we'll see all messages that are being sent to the Swift chat room. Let's get into SwiftUI. So this is how you build UIs in iOS these days. So it's the modern way of building iPhone apps. In SwiftUI, everything is a view. Views tend to be composed of multiple smaller views. There's a special view called a VStack, which lets you have a column of views. Similarly, you have a HStack, which lets you have a row of views. And then the final one is a ZStack, which lets you place one view in front of the others. What you show in a view can be conditional, so you can have if this condition, then show this view, else show that view. You can jump from one view to another using something called a navigation link. So it's a bit like following a URL in a web app. You can pass parameters between views, and by default it's passed by value. So if the child view makes any changes, though they don't get reflected, but you can tag it to say that it's a binding, then it becomes passed by reference. Any changes you make in the child view or the sub view will get reflected back to the parent. What you see in the view is controlled by state. And that state is your model, and in our app we've linked that with Realm. So if something changes in the UI, that will automatically update the Realm database. If something changes in the Realm database, for example, a new message gets synced, it will be reflected in the UI. Final comment on views. Here's a look at our app, and everything you see in the braces here is a view. So the title at the top is a view. The first message about that coffee, that's a view. The empty space to the right of it is a view. So as we go through this, you'll see we create lots and lots of views. So with that, let's go ahead and build our app. Whoops. Okay. So the first thing we're going to do is let's start with the iOS app. So I go to Xcode, and within Xcode, I say I want a new project. Make sure that iOS is selected. It's a regular app. Click Next, and then we can choose what we want to call it. So let's call this Vox Chat. Make sure that the interface is set to SwiftUI, and then we go ahead and create it. Because we're going to be using the Realm database, we need to use the Realm SDK, and that's very easy with Xcode. You just need the repo. So we take a copy of the repo, go to Xcode and say File, Add Packages, and then paste in that URL. And in this case, I know that I want to use the version that is 10.24.2, which is actually the latest version. Okay, that was quicker than I feared. Okay, so that's in there. We then select where we want the application to run. So you won't see it on my iPad, so I'll just choose one of the simulators. And I'll just put that to run to, I did Command R to put that to build and run, so that'll build in the background. So we need our backend database. So I'll just create a simple, actually I should have, let's go back. So to create your database, you just need to navigate to cloud.mongodb.com, and we're going to create an Atlas database. I'm going to use the shared tier, and within there I can actually have a free instance. So all of the default options are fine. So just go ahead and create the cluster. I don't care about any of that. So our cluster is now spinning up. So that's our database. We also need a Realm app to do the sync. So I go to the Realm tab, build your own app, which sort of basically doesn't set up anything for you. Next, so the only thing I need to do is I need to say where the data is going to be stored. So cluster 0 is the database cluster we've just created. Let's call it VoxChat. And try creating the Realm app. Okay, and the only thing I want to set up in here is setting up Realm Sync. So I'll go to the Sync section, say Start Syncing. I don't have existing data in the database to infer the schema from, so I'm going to skip that and say no thanks and just create the sync. As I said, we're going to use partition-based sync. Enable development mode, which means we'll infer the schema from the objects in our mobile app. Got to say what database cluster we want to connect to, give a database name. Let's call it VoxChat. And if you recall, we're going to use the name of the chat room as our partition key. I'm just tell it it's a simple string. And for permissions, I'm going to leave those empty, which means we don't stop anyone from syncing whatever date they ask for. Obviously, in a real app, you would go for something a bit more restricted than that. So we review and deploy, and that's everything we need to do for the back end. The back end's completely set up. So we just click on this icon to take a copy of the application ID. And our front-end app is going to use that to connect to the back end. So let's go back to our iOS app. Okay, so there's a bunch of files that have been created. To be honest, not very many compared to most frameworks, but the one we're going to go to is the VoxChat app.swift. And we know this is the entry point because we've got a tag here or an annotation saying this is the main. And then within here, we've got our view which calls content view. And content view is it's just a simple text view saying hello world. And if we look at the simulator where I ran it, that's there in the simulator. So let's start adapting it for us. So we need to connect to the back end. So we need to import the Realm Swift SDK. And then let's connect to that back end Realm app. So when we call the constructor, we have to just pass that ID that I've just copied from the backend app. And because SwiftUI and Realm both use the name app, I just need to be explicit here to say this is a SwiftUI app. So now we're in the top level view and we can start building this. So the first thing I'm going to do is I'm going to create a navigation view. So almost every app you build is going to have one of these. It's what lets you do things like follow links, add titles, etc. So we're almost always going to have one of those. I'm going to have a state variable, and that's going to be the username, and we're going to use that to understand whether or not the user is logged in or not. Once the user is logged in, we're going to set the username. That means that we can do a test on that. So if the username is an empty string, then we can say that we can just have a simple text view saying that we need to log in. If not, we can have another text view saying that we're logged in. And if I do Command R, what have I done wrong here? Oh, the error messages in Xcode can sometimes be a little bit cryptic. While that's building, I'm just going to organize this a bit. I'm going to create a group to store all of my views. There we go. So now it's saying need to log in. So let's have a group called views. And let's put that top level content view in there. Okay, so now I need a view to actually log in. Let's create a new view with Command N. I check that it's a SwiftUI view, which will give us some boilerplate, and let's just call it login view. So login view, so after I log into Realm, I'm actually going to store the username, but I need to pass that back up to the parent. So to do that, I need a binding which is a string. And so now I can go back up to content view, and instead of having this text view, I can just say login view. It tells me I need to provide a username. It also tells me it needs to be a binding. So to turn the username variable into a binding, I just put a $, in front of it. So within here, I'm not going to display very much. I'm just going to display a progress view. And a progress view is a spinning wheel. But when this view appears, I want to run some code. And the code I want to run is, I'm going to have a function called login. And that's going to log us into Realm. So we need to write that function. Okay, so logging in could fail. So I need to catch any exceptions. And so if I get an exception, I'm just going to print an error message in the console. And using string interpolation, I'll use the error message that's associated with the exception. Okay, and now within here, I can actually do the login. So I'm going to let user equals the Realm app that we've created, login, and for credentials, we're going to use anonymous. So you could use username, password, Facebook, Google, whatever you fancied. It's warning me that that throws an exception. So we'll do a try. and it's also asynchronous, so we need to do an await. Okay, and now that's assuming that succeeded because we haven't had an exception. We can do username is the user's ID. So now we did Command R to build again. And we've actually logged in. Cool. So popping up to content view, we've done the login, but now we need to display something useful if we have actually logged in. So let's create another new view. This one I'm going to call rooms view. And this is going to, it needs the username. So that's going to be a parameter that has to be passed in. So let's go back up to content view, get rid of this and say rooms view. It's going to prompt us, we need the username. It's not a binding this time because it's going to be read-only in rooms view. Okay, so we've now plumbed that in. We're going to need a list of all of the chat room names. So we're just going to hard code that as an array. So we could have Java, we could have Kotlin, Swift, and let's say Python. So we want to display those as a list. So we create a list view. Let's give it a title so we know where we are. So let's do the navigation bar title and just call this one languages. And within our list, we're going to loop over each of those rooms. And pass in the room name as a variable, and then we can just say it's a text view and we pass in room. So let's do Command R to build that. And we now actually see that we've got the title languages and we've got a list of these rooms. But if I click on them, nothing happens yet. So this is where a navigation link comes in. Let's create a navigation link. We have to pass it in the destination. So let's make the destination just be a simple text view where we say the name of the room and then chat room. For the label, I don't provide it inside the parenthesis because we can have what we call a trailing closure. And so this is what we're going to display on the view. So this is what we display on the view. This is where we go if someone clicks on it. So let's build again. And we've now got the little chevron there, and we can click on a room and we're taken to that room and we automatically have a back button. So this is what the navigation link within the navigation view is giving us. We now actually need to start working with the data because the next view we're going to create lets you send messages and display the messages. So we're going to need a model for that. So let's create a new file. It's just a regular Swift file rather than a view, and let's call this chat message. We need to import SDK and then create a class for our model, and let's call it chat message. And for it to be storable in Realm, it needs to inherit from the Realm class object, and also object key identifiable will let SwiftUI know which objects are unique. Within here, we need to create our variables, and we tag them with @persisted to say that we actually want them storing in Realm. So we're going to create a bunch of these. So let me copy that. Because we're syncing with MongoDB, we have to have an underscore ID, and that has to be of the type object ID, which is a Realm and MongoDB type. If you recall, we have a room, the name of the room, which is a string. We have the author of the message, and we have the body of the message or the text. And then finally, I'm going to include a timestamp for when the message was created. That's just the current time. And that's our model defined. That's all that there is to it. So we can go back to our views and let's create a chat view. So the chat view is going to display all of the messages for a particular partition or a particular chat room. So it's going to need to know a couple of things. It's going to need to know the username, so it can include that in any messages it sends. And it's going to need to know the name of the room. So it needs those passing from the parent. So we'll go back to the rooms view. And so instead of having this destination be our placeholder, let's make that be a chat view. And again, we're prompted that we've got to provide the username and the password. Okay, so something that it may seem a little complex at first is we've got to pass it in the Realm configuration. So we're going to create an environment and an environment variable, and we're going to pass in the Realm configuration. And we create that configuration from the currently logged in user. So we get the Realm app. So this is how we connected to the Realm backend. Current user, have to escape it because it could be nil. And then we create a configuration from there. And the only thing we have to provide to the configuration is the partition name, and that partition name is room. So now within our chat view, we can read the data from Realm. And we do that using something called observed results, for which we'll need the Realm SDK. Observed results, that's going to be, we have to tell it what type those results are going to be. So they're going to be chat messages. And then we store that in a variable that we call messages. I also want those to be sorted. So I'm going to provide a sort descriptor where we're going to sort on the timestamp. So that's our Realm results. So we're going to loop over those and display them all. So in our view, we're going to have a VStack. So remember that lets us have a column of views. While we think about it, we can add a label to that. And we'll call that, we'll just give it the name of the room. Okay, so what else do we want in here? So we want a list of all of those messages. So let's loop over all of the messages. And let's start off just by displaying those as a text view. So it's going to be the message and then the text variable within there. But if you remembered when we looked at the application in the presentation, we want to shift messages that I've sent over to the right. And if it's from someone else, I want it shifted over to the left. And we do that by embedding it within a horizontal stack. And it's very simple logic that if the author of the message is the same as our username, so in other words, I sent it, then we put a spacer view, and that's going to take up all of the space on the left before the message. And then conversely, if it doesn't match, I want to put a spacer after the text message, and that will push it over to the left. So let's just build that to see if we can view it. It may take a couple of minutes. So below that, we're going to want to have, here it comes. So now we can go into the Swift room. Haha. There must be a primary key property named ID on a synchronized realm. So that's something I forgot to do. Let's go back to our model. What it's telling me is that ID needs to be labeled as a primary key. So let's do that now. Go back to our chat view. So we want our list of chat messages, and then at the bottom we want to have a space to type a new message and a button to send it. Okay, so now we can go into the room. We've got the title, but we don't have any messages yet because we haven't sent any. So let's put a spacer so it forces our form down to the bottom. And now let us create a horizontal stack, because we want somewhere to type the message and then a button to send it. I'm going to need a local variable to actually store the body of the message. So let's call it text, initialize it to an empty string. So to type it in there, we have something called a text field. So we have to give it a label, so new message, and then pass it a binding to that new variable we've just created. And to the right of that, we want to have a button. And the action is, it's going to call a function called send message, which we'll have to write in a second. And we're going to display, so what we want to have is a little image of a paper plane that people can click on to send. So that is an image view where we give it the system name. So this is just images that are built into Xcode. So a filled paper plane. I want to disable that button if we haven't typed any text yet. So if text is empty, then disable the button. Let us now go and create that function. So we're going to create a new message. And then we just need to initialize the field. So let's set the room to be room. Let the text be the body of our message. And finally, the author is the username, so the currently logged in user. So we've created that chat message. All we have to do to store it in the database is add it to that live query. So at the top we have this live query where we're storing it in messages. So we'll just do messages, append, and pass in our new message. And then the final thing we need to do is we'll just set the text message back to an empty string so that we can send another one. So let's do Command R to build and run. So let's try sending a message. And we can send it. So it's working, but a couple of things to note is it's not very pretty at the moment. So the first thing we want to do is let's just put a spacer, padding around the whole view, because if you see here it's going right to the edges, which we don't want. And for each of these messages, let's put a bit of space between each of those. For the text field, we can put a bit of styling there, so we can give that a bit of padding as well, have a bit of space around it. We can give it a background color, and we can give it a nice shape using clip shape. So now when we build and run, it should look a little bit prettier. Okay, that looks a little bit better. And just to prove it works, let us switch to a different simulator. And build for that. So let's run both instances. So those are the messages. And we can send those messages backwards and forwards. Let me quickly go to our backend database, just to show you that, as I said, the Realm sync, as well as synchronizing between those two instances of the app, it will also synchronize with our cloud database. Contending with hotel Wi-Fi. There we go. So we can look at our collections, our chat messages, and we can see that's in there. So I'm actually going to clone one of those messages and say that this comes from Andrew, and say sent from Atlas. And if you watch, when I click insert, you should see it appear in the mobile app. A bit odd, I expected it to be at the bottom, but the reason it isn't because I'm sorting on timestamp, but I didn't change the timestamp. So let's just pretend that I sent this a second later. And you can see it changes the order. Something else that's interesting is I can now go and change the room. So let's change this to say that this one is actually in the Kotlin chat room. So if I update this, the message will disappear from this view. But if I go back out and go into the Kotlin room, the message appears there. Okay, so let's go back to the slides just to close out. So I wanted to quickly review what we've built, and the key thing that I want to get across is I was going backwards and forwards a bit so we could build it iteratively, but in total there's less than 100 lines of code needed to build a functioning chat app. And most importantly, what you didn't see me build, so the code we didn't have to write, which I think is really, really cool. No code about storing the data locally on the local file system. I've not demonstrated it here, but I could disconnect from the internet and continue to read the messages in all of the chat rooms. And also I can actually send new messages. And then when I come back online, those messages will sync and appear in the other instances of the app. We didn't write any code for an app server or a database or authentication, etc. That was all provided by the Realm backend service. real-time bidirectional synchronization, and again I didn't demonstrate it here, but that does include conflict detection and resolution. We got the partitioning, and something that is more work than you might think is automatic translation of the documents. So rather than have, so I could go and create a Kotlin version of this, and in fact if you follow that QR code in the repo there is an Android version, and there's no code we have to write to convert our Swift objects into Kotlin objects. That's handled by the Realm sync. And also there's no code to convert them into the MongoDB documents which we're storing in the Atlas database. And then finally, the other thing you didn't see is any event handling software. So when things change in the database, the UI automatically updates. So you don't have to go observing, waiting on any flags or anything like that. That's all handled. And so that's why, and this is the reason why we can actually build a functioning app in so few lines of code. It's because the platform is providing so much of it for us. And so I just wanted to finish by again pointing you to that repo. And in that repo, you'll see that there's actually multiple. Actually, let's go there and see. Within there are multiple branches. The one we've used today is actually no, that's the wrong one. Multiple branches. The one we've used today is it's the 45-minute one. But if you go to the main branch, then this actually, it's got the Kotlin version, and it's also got username authentication, so it's got some extra sophistication in there if you want to try that. And so with that, I think I can stop sharing my screen.